So hello everyone, welcome to another video. And in this video we're going to solve a new question related to a data structure called linked list. And here the question is to reverse a linked list. And let me show you what is a linked list in on the whiteboard first before solving this. So linked list is a object-oriented data structure where every value has a property called value where you're going to store its own value, and there will be a pointer pointing to another node. We can say node or similar structure of the previous one. For example, see, we have a object called this is a object, right? We have a property called val, and we're gonna store some value called 1 or something here, anything. But it will also have a pointer called next, and the next pointer will be pointing to another object. So this will be a similar object again that will contain another value, maybe 2, and we'll have again the pointer. And as we add values, the structure, the chain structure will keep increasing. Keep increasing. At the let's call the first node edge head, and where we get next equals to null, that will be our tail. Okay, this is the common our linked list structure. Okay, so now in our case it says to reverse the linked list. To reverse the linked list, we can do it in two ways. One is like by pure variable way, by creating a variable way, in the sense, or we can say that for every element, when we're gonna traverse through the linked list from left to right, for every element we're gonna create a new kind of node. We can call it node or this object, right? We're gonna create a new object and keep assigning values, or we can call it new node as well. We can, for every element we're gonna traverse from left to right, we're going to create a new node. So basically in this process, when we return the linked list at the end, the reverse list, right, that will be a completely new object. It is not the same object we gave as an input. But there is another way to reverse the linked list is by using reference method, right? Reference, in the sense, we're going to use same object, but in this particular object we're going to keep changing the references. For example, if we reverse it, what it will become like val, right? So the first value will become this 2, right? This val become 2, then next become this 1, and this pointer will become null to the next pointer of the variable 1 will become null. So basically we can do that by changing reference. For example, by changing this next reference to the tail reference, right? Those kind of stuff. And we're going to keep save it somewhere. And then again, when you go ahead, we just keep changing the references. In this particular way, we don't have to use extra space. So this will become always OF1. But in this case, where we are using a new variable to reverse the linked list, it will need the same amount of extra space. So the space complexity will become OFN. The time complexity in both cases is OFN. But the space, but in the reference method, we're going to save some space, and in variable method, we will be using the same amount of space as the original one. So now we're going to do one thing. We're going to solve it in both the method. So let's go ahead and do first our, let's call it replacement method or something like that. Okay, replacement or variable method. Okay, so in this particular case, what you're going to do is, let's imagine first, always in this kind of problem, create a simple linked list, right? For example, that's the example, val equals to 1, next will be val equals to 2, and next null. So let's take this list as an example. Okay, now first let's create a variable called node is the same variable as the input linked list, and we're going to create a variable for reversed list, or we can call it a result, maybe. Yeah, result. Let's call it null. Okay, now while node and our best case, our loop case will be like node equals to node dot next, right here. So every time, for as we explained on, as we show on the whiteboard, right? Every time it goes to first pointer, we have to assign it to some new variable. So this is the new variable. Let's create a new object with same property that contains two properties, same properties, val and next. So when we reached at 1, we're going to take 1 and we assign that 1 to the new object's val. So this will be node.val, and the first heads next should become null. So we already created a variable called result, so we're going to put that result here, right? And then we have to save this value, and whenever the second whenever our pointer goes to 2, right, next iteration, we're going to use this reverse as the next, and we'll keep saving it. So rather than creating an intermediate new variable, we can save it to the same result, and it will keep saving the same values and keep putting it there. So at the end, we're going to return result. So this should return our reversed linked list. Let's see. I have already written the test cases. So this one is for the replacement method. So let's try. So as expected, it returns the reversed linked list. So now let's try our reference method. So this will exactly the same. We're going to create a node and assign the input linked list, and we're going to create a result as well. Okay, and we're going to assign null. Here the process is different. We're not going to create a new variable, but we're going to just we're gonna play with the references so that we will not gonna need extra space. So let's do that. So same, everything remains, the loop structure remains the same while node. Now here is the case. Whenever we reach at val 1, just visualize this same linked list that is there on the screen. Let me copy that to here as well. So whenever that is in 1, our next should become null, right? That is our goal. That should go to last of the linked list, and that the next should become null. So let's do it. So node dot next equals to result, because result is null. But the thing is, like, if we make it like node.next is result or null, we're gonna lose the value of next that is there, that's there in the given object. So first we're going to save it to an intermediate a temp variable. So let's call it like next equals to node dot next. So now we are safe because first we saved the node dot next to a intermediate variable, then we assigned that next to assign null to that next. So we get our value here, node value is 1 pointing to null, and here our next became 2 and null. Here then here in next, what's gonna happen, 1 and null should go to our next, right? So what you're gonna do is we have to assign result to node. So whatever 1 null we're gonna give to result. So because when it's gonna become 2, our next will become 1 null, and that's what we want. So let's give the node to result. So result will become like 1 and null, right? And at the end we have to iterate, right? So node value, because we are iterating on the node variable, so node value should become now 2. It started from 1, now it should become 2. So we'll see which value in our loop contains that 2 value, that is next. So we should be assigning this to next. At the end, return results. Simple. So this should solve our problem, and let's run the test cases for this one as well. So it passed. So now we solved the reversed linked list question using 2 methods. One is our variable method, or we can call it replacement method, and second one is like our reference method. So in first method, the time complexity of both the method is OFN, because we have to traverse through the whole linked list. And but in reference method we don't use any extra space because we are just playing with the references, so the space will remain OF1. But in case of reverse in case of our replacement method, for every object we are creating a new object, so the space complexity will become OFN. As simple as that. Thank you.